So if you have oxidation of Fe2 plus to become Fe3 plus using potassium dichromate ion, or just use the dichromate ion to show in the equation, and they should be changing into Cr3 plus. This is very important, and then using the normal way of balancing, we will write the two half equations. So how to write the half equation? This one will lose electrons, so I'll just put the plus electron there. This is 2, so I'll just put 2 there. Oxygen is going to be given in form of water. And then there is no hydrogen here, so I'll just put the hydrogen here. And there is 7 atoms of oxygen, I'll just put 7 here. And I have 14 hydrogen there, so I'll just put over there. And the last part is to balance the charges. So the charges over here, 2 times 3 is plus 6, this is 0. This is negative 2, this is 14 times 1, so 14, 14 minus 2, that's going to be 12. So we can actually decrease the number so that we can balance these two numbers by introducing electron. So electron will bring the number down. I do not bring this number down. I'll try to bring this number down to 6. So I will add 6 electron. So when I add 6 electron, this is plus minus 6. So you are going to get each electron is 1, negative 1. So you will get 6, 6 and 6 is balanced. And finally, I'm going to add these two equations and we are going to eliminate the electron. In order to eliminate the electron, the number of electrons must be the same. So I just put the 6 over there, 6 over there, 6 over there. I add. And finally, this electron and this electron will cancel. Finally, I will get 6 Fe2 plus 14H plus Cr2O7 2 minus. One done. To give you 6 Fe3 plus 2 Cr3 plus 7 H2O. This is the balance equation. So now the question is, we are going to give you, the question is going to give you an unbalanced equation. So let's say I'm just going to put Fe2 plus here and Fe3 plus here. And I'm removing the 2, I'm removing the 7, removing the 14. And the question is asking you to balance this particular equation. And they might actually give you A, B, C, D, E, and F. And ask you, they will give you certain values, certain numbers for A, B, C, D, E, and F, and ask you which combination are going to be suitable. And they will actually give in the question itself, use oxidation number method, to balance this equation. So the moment they say oxidation number method, do not try to use the normal method. This is already telling you that you cannot use the normal method. The normal method, what I mean is the normal balancing chemical equation, because in order to balance this, you need to consider the electrons. You cannot use that method. So if they have already said using oxidation number method is only used for redox reaction. Please remember that. You cannot use this method for any kind of equation. So don't actually say that, oh, I learned this something new, I'm going to apply for everything. No, only for redox reaction. Therefore, when they ask you in the question, they will mention to you, use oxidation number method. That's already helping you. So now, how to do this? First, you see this Fe2 plus and Fe3 plus. They are going to be oxidized. The number, oxidation number is plus 2. The oxidation number is plus 3. From 2 to become 3. And first important is to look at how many Fe we are talking about. 1, I'm talking about 1. So no issues. 2 to 3. So there is an increase of 1 unit. Now, the problem is, okay, if you use the normal method, if you want to show from here to here, what we normally do, like what we did yesterday, okay, was the wrong part, which is you need to find what is the oxidation number of Cr. You can actually just memorize. Last time I told you potassium dichromate 6. If you know that, automatically it's 6. But if you don't know, no problem. Cr2O7, 2 minus, you calculate. This is 2, this is x, 2x plus 7 times negative 2. Oxygen is always negative 2. Equals to negative 2, you calculate 2x equals to negative 2. This is negative 14, you bring it over there, plus 14. That's 12, x is going to be 12 divided by 2. Then you will get 6. So it's 6 plus 6. And this is going to be plus 3, but be very careful. It is not going to be 6 to 3 like what you will normally do, which is negative 3 you will put. Yeah? But this is, we are dealing with 2. Even though there is no 2 here, it is important to acknowledge we are going to actually deal for 2 atoms of chromium. If it is 2 atoms of chromium, this is the oxidation number for 1 atom of chromium. So you are not going to put this as plus 6. For this calculation, you are going to put it as plus 12. Very important. Now, doesn't matter on the left, on the right, okay, once you have 2 or 3, you times, okay. Here, even though there is only 1, okay, but do remember we are talking about 2 chromium. In one point of time, they are going to have 2 chromium over there. So, this is no longer going to be plus 3, even though there is no 2 there. This is automatically, we are talking about, in this particular equation, we are talking about 2 atoms of Cr. So, it means that this is no longer plus 3, this is plus 6 times 2. Okay, because we are dealing for 2 atoms of chromium. Not from just here, we are looking at it overall. Okay, overall. If you are looking at this 2, it means that is considered to be 2, even though we haven't put the number yet. Okay, this is the trick over here. Now, once you have that, 12 to become 6, this is going to be minus 6. And the rest are the same. Find the same ratio. If this is minus 6, this is plus 1, you need to make it into plus 6. So how do you make it into plus 6? You times this by 6. Okay? When you times this by 6, automatically, no problem if it is only 1. Yeah? Fe is 1, Fe3 plus is 1. No issues because you no need to think a lot. Just put the 6 over there. 6 and this is 6. Why? If you put 6 over here, definitely 6 Fe, you must have 6 Fe over there. Okay, there is no problem if you are dealing with 1 atom. Okay, but in this case, this is times by 1. Although they say times by 1, you need to be very careful because if this becomes 1, okay, if this becomes 1, we are dealing with 2 chromium atoms. On the right, okay, you don't actually end up putting 1 over here because I told you eventually the 2 will come up. Why? Because 2 atoms of chromium must have 2 atoms of chromium here. So you need to put 2. Okay, even though the number here is 1. Okay, you balance the oxidation number first, then you put it in. Now, we have this number in, we have this number in, we have this number in, and this number in. The rest, you just need to balance like normal. You see, yeah? This is confirmed. Okay, confirmed. So if you have 7 atoms of oxygen, you must have 7 atoms of oxygen over here. How do you get 7? You put the 7 over there. Once you put the 7 over there, you are going to have 14 hydrogen. So you put over here 14. So now you compare with your existing answer. Okay, this is going to be 6, 14, 1, okay, 2, and then you have 6, and you have 7. Okay. NH3 plus O2 to give you NO plus water. You try. Check the oxidation number, okay, of nitrogen, okay. Nitrogen, okay, so X, okay, plus 3 times H is going to be plus 1, overall is going to be 0, X 3, so negative 3. So this is negative 3. This one, X minus 2, okay, oxygen is negative 2, equals to overall is 0, X equals to plus 2. So this is going to be plus 2. So 1 and 1, no issues. Okay, so from here to here, okay, make sure, okay, you don't do this wrongly, yeah. So this is negative 3, this is 0, negative 3, this is 2. What is the difference? It's 5 units, okay. So don't go and say 1, okay. So this is going to be 5, so this is gain of 5. Okay, and then now here, oxidation number of element is 0. Okay, we put 0. Oxidation number of oxygen in any compound is negative 2. Okay, so if you want to count also can, you just put negative 2. But now, be very, very careful with this, because we are not dealing with one atom of oxygen. You check left and right. We are dealing, even though this is 0, we are dealing with 2 atoms of oxygen. So 2 atoms of oxygen, so this one doesn't matter, 0. Okay, but this is not going to be negative 2. You need to consider 2 atoms of oxygen. So this is going to be negative 4. Okay, so from here to here, okay, that's going to be not decreased by 2. This is going to be decreased by 4. Okay, this is important. Now, once you know this, you find, okay, 5 and 4. You want to find the same ratio, okay? So you can find the common multiple, which is going to be, you times this by 4, you get plus 20. You times this by 5, you will get minus 20. So you are going to get the same the same ratio, okay? And what we are going to do now, okay, for this is going to be easy, because why? 1 atom of nitrogen, 1 atom of nitrogen. Just simply put, okay, close your eyes also, you can put just 4, no issues. 4, and then you put 4 over there. Okay, that's not an issue. But the thing is, we need to be very, very careful when it comes to here. Okay, this is going to be 5. I need to find out, where do I put the 5? Do I put it here? Do I put it here? Now, it is important to know that this 5 is like very important, you know. 5 means, okay, in that ratio, this is going to be for 5 for that oxygen. If you look at left, there's only one reactant that is involving oxygen. If I look at my right, if I go and put 5 over here, it's not going to be fair. Why? Because you are ignoring this oxygen. So, you don't go and put that important number 5 over there. The important number 5 should represent all the oxygen that you have. So, that is going to be 5 will come over here. If, let's say, you go and put the 5 over here, you will not be able to balance. So, therefore, maybe you can still do trial and error. Yeah, but you're still on the right track. Okay, but eventually, if you put the 5 over there, you will not be able to balance. Okay, so you come back over here. Maybe if you got stuck, you come back again. You go and put the 5 over here. You try. Okay, you try. If you put the 5 over there, okay, we are going to have total 10 oxygen atom. Okay, if you have 10 oxygen atom, you need to figure out how do you get 10 oxygen atom, because that's the number, you know, the 5 is the ratio. I need to figure out how do I get 10 oxygen atom. And this number is a magical number. I told you, the number 4 that you put. You don't go and disturb this number anymore. Don't disturb this number anymore. It means that this 4 oxygen is fixed. You don't go and disturb them anymore. This is 4. I need 10 oxygen. So the remaining 6, I must get it from here. You no need to think a lot. I need to go and disturb this. You put the 6 over here. When you put that 6, oxygen is balanced. The last is hydrogen. So you need to have 12 hydrogen. You come back again, you check 4 times 3, 12 is balanced. So this is how you balance using oxidation number. Okay, so let's try. This is actually, maybe you can see, the easiest was yesterday, okay, when you use MnO4. Okay, then today, just now, I show you the Cr2O7. Okay, and that concept, we are applying it here. Okay, but of course, when we keep on trying different types of question, okay, we want to make it harder a bit. Okay, V3 plus. So here, okay, again, similar, okay, I'm going to select this, I'm going to select this. So the important thing is to select which one is going to give you oxidation, which one will give you the reduction. So you must select the proper one first. Okay, and then here, I'm not going to select H. You see here, H is always +1, this is always +1. That's the reason why I'm not selecting H. Okay, so I'm going to select this and this. Okay, so first, I'm going to select the easiest one because 1V. Okay, so oxidation number is +3 here. Oxidation number is X minus 2 equals to +2 overall. So X equals to +4. So this is +4. So confirm, I know it is changing from 3 to 4. So this is going to be +1. Okay, no doubt in that. Okay, but now from here to here, this is going to be element, so 0. This is going to be -1. But be very careful, it is not going to be -1. Okay, it's not from 0 to -1. Why? Because we are dealing with 2 atoms of iodine. So if 2 atoms of iodine, we treat everything on the left and right, it is some sort of dealing with 2 atoms of iodine. So this one 0. This one cannot be -1, okay, because we are dealing with 2 atoms of iodine. So this one you need to times by 2. So this is going to be -2. Okay, so it's going to be from 0 to become -2. So this is going to be -2. That's very important. And then now you try to get the same ratio. Okay, so you times this by 2. So +2 -2. Okay, so this one is times by 1. So this 2 is a magical number. When you put 2 here, this is since 1 and 1, so you no need to worry. You just close your eyes and just put 2, 2, done. Here, you need to be careful a bit. Okay, because the number is supposed to be 1, even though you close your eyes and you put 1 here, you need to be very careful. Here, even though you put 1, there is 2 atoms of iodine. Here, the iodine is only coming out in form of iodide ion. There's no iodine here, no. So there must be 2 atoms of iodine. So there must be 2 here. Very important. So you have balanced the important part. The next is to look at balancing the hydrogen or the oxygen. Now, don't go and balance hydrogen first. Okay, why? Because these are the confirmed numbers. These are the confirmed numbers over there. And from the confirmed numbers, you do not disturb the confirmed number. It means that oxygen is in one part, okay, they have the confirmed number 2. It means this oxygen must be always 2 atoms of oxygen. So you need to figure out, how do I get 2 here on the left? So you must put 2 here. Once you put 2, hydrogen is going to be 4, then you put 4. Now balanced. You have this Cl2 plus OH minus to give you Cl minus plus ClO3 minus plus H2O. Now you will appreciate the method that I taught you, okay? Because now is we are going to look at it, okay? First, we need to identify, okay, which one is oxidized, which one is reduced. But now, okay, there is a problem over there because the same, okay, compound is being oxidized and reduced. So what I will suggest, you take from here to here. Okay, this is going to be the one that is going to be from 0, supposed to change into -1, but we are dealing with 2 atoms of Cl. So you don't use -1, okay? You use -2. Okay, so that is going to be from 0 to -2, that's going to be decreased by 2. Now, I want to show for oxidation rather than just showing like this to go there. Okay, I will suggest to look at it in a different way. Separate them. Write the Cl2 here. Okay, write the Cl2, later we combine. Okay, write the Cl2 here. You put from here to here. Okay, it's the same Cl2. Okay, so now this is 0. What is the oxidation number over here? Yeah, so x plus -2 times 3 equals to -1. X minus 6 equals to -1. X equals to -1 plus 6. So plus 5. This is supposed to be 5, but check again. This is Cl2. Okay, 2 atoms. Okay, so you deal with 2 atoms. You don't use 5, you use 10. Okay, so now from 0 to 10, that's going to be plus 10. Now what you do? You find the ratio. The ratio over here is this is going to be times by 5. This is going to be times by 1. When you have times by 5, okay, you need to be very careful where do you put. But since we are dealing this separately, and this is, we are assuming everything from here is going there. Everything from here is going there. So you no need to worry so much. Okay, so everything from here going there means if this is 5, the magical number, so this is 5 times 2, that's 10. Automatically, this must be 10. You don't worry about that because I'm dealing it separately. Okay, so this one times by 1. Okay, you close your eyes, you put 1. Okay, no problem. You put 1 times 2, that's going to be 2. 2 atoms of Cl. So you bring it over here. You don't bother about this because I already done it separately. So this one must be 2, not 1. Okay. So once you have that, okay, all the important numbers has been balanced. So I am going to take it out, okay, because it's a bit messy over here. When I take it out, you see Cl2 and Cl2, they are going to be 5 plus 1 together. Put it together. So 5 plus 1 is going to be 6 Cl2. Okay, I have balanced this. But OH I have not balanced. I have balanced 10 Cl minus. I have balanced 2 ClO3 minus. But I have not balanced H2O yet. So the one that is not balanced over here, maybe this is X, this is Y. I have not balanced yet. So now you have to do the trial and error method. Okay, what is trial and error method? If Y becomes 1, okay, if Y becomes 1, what will happen to the number of hydrogen and oxygen? Hydrogen, okay, is going to become 2. There's no hydrogen here. Oxygen is going to be 2 times 3, which is 6. If this is 1, so 6 plus 1, that's going to be 7. Okay, you check 2 and 7. When I look over here, whatever number that I put, if I put a number, oxygen and hydrogen must be the same. Okay, if I put number 1, 1 oxygen, 1 hydrogen. If I put 2, 2 oxygen, 2 hydrogen. If I put 3, 3 oxygen and 3 hydrogen. But the number is not the same. So I need to try until I get the same number. So let's say y equals to 1 is not an option. Let's try y equals to 2. When I put 2, this is going to be becoming 4. Hydrogen becomes 4. Oxygen, 6 over here, plus 2. So I'm going to get 8. So you see the number is not the same. So it's not suitable. So you try 3. When you try 3, hydrogen is going to be 6. 6 plus 3 is 9. You see the number is not the same. You try 4, okay? So this is going to be 8. 6 plus 4, that's going to be 10. Not the same. You try 5, hydrogen is going to be 10. 6 plus, okay? You try 5, so this one is going to be 11. So not the same. You try, okay, 6. That's going to be hydrogen, 6 times 2, 12. Oxygen is 6, okay? And then this one, if I put 6, 6, so I get 12. Same and same. Why? When I put 6 only, I am going to get the same hydrogen and oxygen. So if I put 6 here, I will have 6. I will have, I'm looking for 12 and 12, yeah? So this one will be 12. Okay? So now, that's going to be my answer. And supposed to be, if you want to check, good way that Rico actually highlighted. If you want to double check, the charges must be the same. You can double check. 10 times negative 1, negative 10. 2 times negative 1, negative 2. This is 0. Total, you get negative 12 on my right-hand side. So here, 0. So this is negative 12. Left and right balance, done. Okay. This is, done.